Hello, hi everyone. Thank you, Christian, for introducing me. So, hi everyone. Yeah, this is a December meetup. So we are all thinking about Christmas, I guess. Yeah, it's the last meetup of data modeling meetup Munich, DMMM. So it's the last meetup of the year, and I'm very happy to join with you a topic that I've not covered before. It's a topic that I worked on, but I never spoke in a public speech about this. So it's my first time. And as Christian said, I am very much oriented to having you asking questions, but not only questions, but in general remarks, because it's a topic that JSON is a topic that many people know about, but there are still a lot of doubts about the topic, and even I don't own the full knowledge about this topic, and I'm very happy if we use this meetup as an occasion to learn together. So let me share my screen, screen one. Yeah. So you see my screen, right?
Yes, we do.
Good. Okay, so data modeling with JSON. So, right. I want to reduce to icon. Yes, it works. Good. So about myself, quickly, I am a consultant in business intelligence. I started in 2001 this job, and I love it. So I was working a lot in business objects, so which now is a SAP tool. But when I was working on that, it was a self-standing company. And with business objects, I got acquainted with the SQL language, of course. And then after a while, after doing front end, I said, okay, let's go deeper into the source. So I want to work in data warehousing and in Teradata. So yeah, I worked for the Teradata company for 2 years. I was actually not working on projects. I was team lead, so I was following many projects, which gave me a chance to really see what's happening in the data warehouse. So I saw multiple flavors of the Teradata projects, and that was really enriching me a lot. I left Teradata because I was not too happy of the way how they were doing data warehouses, to be honest. But yeah, that's also learning also when things don't look like the way you would like them to look like. And then I started to work again on Qlik. So again in the front end on Qlik and Tableau. I call myself a Qlik specialist very much, and I always use Tableau as a tool for making examples, because everyone can have Tableau, everyone can install Tableau public. So it's a thing that people can repeat at home, and it's very much easier to use as a demo than Qlik. And now my personal interest is moving towards Python and R. There are several reasons for that. The main reason is that I'm a bit tired of BI tools, because I'm tired of the fact that you need to find buttons that do the thing that you want to do. So especially in Power BI, there are buttons everywhere, and I prefer code. So when I want to do something, I just write down the code. So that's where I'm shifting my interest to. And one of the reasons is actually JSON files. So I noticed that the BI tools don't have a very, very good relationship with JSON. It's actually very complex to import JSON files into Power BI. It's quite easy to do it in Tableau, but it's quite simple, like simplified. So it's, in my opinion, it's a bit limited. And in Qlik, Qlik does not have a good relationship with JSON files. Qlik View never had, and in Qlik Sense you use REST APIs, but there are always problems. So I said, okay, let's go to languages which will give us a chance to have a better control of what we do with the JSON file, because it really needs control. And yeah, I noticed now in the Meetup page, I was defined by this Meetup as a data modeling iconoclast. Christian, can you explain that? I like it. I like it a lot. Can you explain why you see me as a iconoclast?
Sure. So I know you as someone who doesn't have too much respect with all the holy cows of data modeling and data warehousing, who really thinks for himself and has his own ideas and speaks his mind. So this is the reason for the iconoclast.
Yeah, yeah, thank you for that. Yeah, let's say that I don't hesitate when it comes to questioning things if things don't convince me. So I definitely want to, I'm not happy with hearing a phrase and saying, okay, that's the way how it is, so let's do it. I rather dig into the reasons why someone says like that. Quite a lot in the book that I wrote, for example, which is called the Unified Star Schema. I question what Kimball says about the presentation layer of a data warehouse. So yeah, I do that quite a lot. And with JSON, I'm still in the phase of discovery, but I've already found some things that probably I would bring to the table now, because I want to hear the opinion of the participants. So why am I speaking today about data modeling with JSON? So first of all, what is the JSON? JSON is, and what is, sorry, yeah, it's covering, okay. It was introduced by this gentleman called Douglas Crockford. And the question is, why was it introduced, what it is, and why do we need JSON today? So there's a video that explains all these things much better than I would do. So I suggest you to go to your YouTube and type the history of JSON at Silicon Valley Code Camp 2019. So there's a speech from directly the father of JSON, who is explaining how he arrived to define this standard, and what was his idea, what succeeded, what didn't succeed. So he says a lot about that. So you don't need me. He will say it much better than me. But the main question is, why am I speaking about this topic today? I speak about this topic because data sources, I hear some background, maybe, yeah.
Yeah, I found the perpetrator.
So the data sources in our projects of analytics are more and more in JSON format. I see it happening more and more every day. Yeah, so we have one more speaker today. Was I the only one hearing a voice?
Yeah, there was a little child, but
okay.
I think the person that has muted themselves now.
Okay. I'm wondering if it was here. And I have a child and I didn't know about it. So there are more and more data sources that are in JSON format. And the problem that we have today is that, as I said, the BI tools are not really good in reading JSON files and interpreting JSON format. So I'm bringing now this topic to the table because I have mainly one idea to share with you today, but I wanted to hear also your ideas and your feedback. So I took this definition of a JSON object from the website json.org, which is, I suppose, the website that was created by this Douglas Crockford. And it's very important to start from this because JSON is basically this slide that you have in front of you. So about the railroad diagram. So in a railroad diagram, you need to think that you are like a train, not like a human. So when you're going through the options, for example, when you're here, you cannot turn like this. A train would not be able to do this. Why am I saying this? Because I'm not sure when I checked it for the first time. Probably you guys know these diagrams better than me. So JSON object is by definition starting with a curly bracket and ending with a curly bracket. And in the middle, it needs to have a white space. White space can be a space or a carriage return, whatever you want to call it, like a separator. So the minimum object is these three things. And then, of course, instead of going here, the train can decide to go here. So you have still a white space, and then you have a string, a white space, a colon, and a value. And then you can go either to close, or you can continue this loop as many times as you want. And this string and value are the famous key value pairs, which actually in the definition that I've seen in the video that I recommended to you, they call it value pairs, not name value pairs. So, and I prefer this way of calling it name value instead of key value, because the word key has also another meaning. So this name ends up being the header of a column when you turn a JSON into a flat table. And a name of a column is head. You can call it header, you can call it name, but if you call it key, that's very misleading, because key reminds the concept of the primary key, while only one or a combination of columns are primary key, but the others are not. So I like a lot this way of calling it name value pairs. So string, this one is the name, and this is the value. Value is the most important thing, because it is, you will see it in a second, it is also not only in the JSON objects, but it is also in the JSON arrays. So JSON basically can have either the curly bracket, which is the object, which is also known as a dictionary, or the square bracket, which is the array. These are the two type of brackets that you can have. And the array is even simpler than the dictionary, because you can just simply have two square brackets with a white space in the middle, or you can have a list of values, comma separated, and then you can close your bracket. But as you see, both have this value thing. So now let's go to see what is a value, because it's the most important. The definition of a JSON value, again, I'm reading from, it's a copy from this website, json.org. A value can be, it's first of all, it has to have a separator on the left and on the right, either a space or a carriage return. And it's either a string or a number, or true, false, or null. So these are constant. Or it can be an object or an array. And this is suggesting that a JSON structure is a recursive structure. So it's technically what you would call it a tree. So a tree is a particular case of graph, and I think most of you know what a tree is. So you can put unlimited levels of nesting objects. Christian, am I still online? Just feedback.
Yes, I see you, I hear you.
Sounds good. Yeah, because I also don't see myself, which I should probably use the monitor. I'm just with the laptop, so I will get a monitor next time. Okay, so a value is either a string or a number, or true, false, or null, or one of these two things, a nested dictionary or a nested array. And that's where things become interesting. So white space, as I told you, can be a space, line feed, carriage return, horizontal tab. So it's just a separator. That's easy. More interesting what a string is, well, actually not very interesting. It is defined by double quotes, and that's it. You can put any text inside, except the famous characters that give problems. So there are all the escapes. I didn't put all of them because it's not interesting. We all know what a string is, and important is that it must have double quote, not single quote. And when it comes to number, again, there is a complex definition, because a number can be in various formats which are supported. So scientific format is supported. Hexadecimal and octal are not supported, but you can still put them in a JSON a value when it is in a string format. So number, again, is not very exciting what it is. But what really interesting is the example here of Wikipedia. So we can see a sample of a JSON object. So it starts with a curly bracket, ends with a curly bracket, and these are the name value pairs. So this first name, John, so this will be like the header of your CSV file or Excel file or your table in your database. So this is easy. This is a string, this is a constant, true, we have seen that. This is a number, of course, and this, it's a name address, and the value is a nested dictionary or object. And then again, as the recursive method says, it can be again a combination of name value pairs. And this for numbers, the value here is not string, but it is an array. So an array has a list of comma separated values, and the values that are comma separated, in this case, they are 2, and they're not strings, but they are, again, nested dictionaries or objects. And then we have, again, this children. It has an empty array, and then suppose there is a null, which is another of the possible constants. So the combinations are not, well, the possibilities are not many, but the combinations, of course, as you can imagine, are unlimited, because you can put unlimited levels of nesting and everything. All right, so here is a question, and we begin to be interactive. I always hear this phrase, oh, okay, there is a JSON, but it's not a problem. We can flatten the JSON. So I want to ask you, and you can either answer by chat, or you, even better, you can activate your microphone. So what is your opinion? Can we always flatten a JSON? Yes or no? And especially I would like to know why, if you say no. I actually unshare for the moment the screen, because I'm very curious to hear from you. Is any of you going to tell me your opinion about flattening the JSON?
So I think we have the first opinion in the chat.
As the key names have to be unique, it is not possible, in my opinion. Okay, that's a very fair point, because if you put a nested dictionary and one of the keys or names already exists, that would be a repetition which is not supported, at least it's not supported by databases. It is definitely supported by CSV files, because they don't have any type of check control at all. But I suppose there's an escape from that, because many programs, for example, are adding a 1 and then a 2, I suppose, if you're repeating the same identical name for a column. What is meant by flattening? Represent one JSON document in one table. Yeah, that's exactly what the community means by flattening. Exactly. So if the question is if it's one or many, no, by flattening, typically people, at least that's my understanding, mean that you take one JSON and that becomes one single CSV or one single table of a database, not multiple. That's not flattening for what I understood, but that's a more complex thing. The answer is an emphatic no. Yeah, okay, so Gabriel, I agree with you. Jane says, yes, but you may not get a usable result. Yeah, okay, that's the usual thing, that can you do it, but should you do it? There's always a difference. Of course, there are many things that you can do. You can also take a gun and shoot people in the street, but you should not do it. So yeah, probably I should have asked, should we do it? Like, because of course, if you get a not usable result, then it's a thing you can do, but you should not do. And Mark says, fun trap. I think I know why he says that. I know Mark, and I guess he has had a conversation with me in the past. And that's actually, he knows where I'm going. That's exactly what I'm going to share in the next slides. Bill got in your mind. He always says that. It's true. I learned this phrase, you can do it, but you should not do it. It's totally from Bill Inmon. He used that a lot in his training of textual ETL. So you're totally right, Martin. Okay, so these were quite a lot of nice feedbacks. And basically, I see that my opinion is matching pretty much the opinion of the people who have answered. So I go on sharing again. Actually, no, that was actually my last slide, because today I want to do more of a brainstorming about live things. And instead of slides, I much prefer opening examples live. So there is a collection of JSON files that I took from Kraken. Kraken is a portal for cryptocurrencies, and it has APIs. And like most APIs, the result set of the API is in JSON format. So there are quite a lot of endpoints this is a list of them. The list is actually bigger, but just for the sake of this presentation, I isolated 7 examples because they have slightly growing complexity. So let's start with this one, get server time. So this is a JSON file. We see that is starting with the and ending with the curly brackets, and it has name value pairs. So this is a empty array, and this is another. This is a nested object or nested dictionary, which has again 2 name value pairs. And this is clearly a number, and this is clearly a string. There's one thing interesting to notice that in the JSON objects, by definition, the dates do not exist. So whenever you need to have a date in your data, then that will be a string because the data type does not exist. I think it makes sense that they have kept the number type because numbers are numbers. They store, they occupy less storage space, and there are 1,000 reasons why numbers are needed to be there. But probably dates were too painful, so the good inventor of the JSON said, you know what, let them people transmit strings in their messages, and then they will interpret them later. So if I ask you, for example, if we flatten this one totally, we flatten it, the entire JSON, how many columns would we have in this case with this data set in particular? So again, I can check the chat. I don't know if I can check it while I'm while I'm presenting. I guess that will create a mess. So I show you again. Sorry, it's here in Notepad. Am I still alone again? Am I?
No, there are other people here as well.
No, I'm scared. So how many columns would we have in our flattened table, guys? That's an easy question. I need you to bring your input because this is easy, but then we go more complicated.
Possibly 2, but maybe more if there's an array.
Okay, so yeah, well, yeah, in this case, actually, that's already the question. Martin is asking what to do with the array. Okay, in this case, we are lucky because the array is empty, so it's a good, it's an easy one. But this is when you have errors, the array is not empty, and possibly you may have multiple errors. So what I've seen many people who are saying, you know what, even if there are multiple errors, this array is still a list of text things. You just put it all in one column, comma separated, so you solve the problem. So that's a quick and dirty way of solving the problem, which in this case is probably acceptable because okay, this is not even data, it's metadata, the error, and hopefully you don't have many errors. And if you do, you can handle them somehow. It's some IT thing, so you're able to unpack the comma separated list. But yeah, that's already raising the question, what happens when actually in the square brackets we have proper data. So I would say I would personally turn this into 4 columns, but someone have answered 2, which makes totally sense to me, because here we have basically in one JSON file, we have the equivalent of 2 tables, because you don't want to mix data with metadata. So I agree that I would put these 2, I would create a CSV file with 2 columns and 1 row, clearly. And then I would produce, only when it's not null, a separate CSV file. I talk about CSV files because it's the easiest thing. When I'm saying CSV file, I mean table in general. So I would produce a second one, which has a list of errors when the errors occur. So in this case, I agree with all your answers. One for error, one. Okay, yeah. So basically, there can be 2, 3. Actually, all answers are good here. So let's move to the next one, which is more interesting. Actually, no, also the second is very easy. Yeah, actually, this is easy, but it raises a point. So here we clearly have 6 currencies. So this is get account balance. So it's telling me I probably own some Link coin, and I own some Pax and Algo. So these are the coins that I own, and this is telling me how much quantity I have. So, for example, I have 1,000 link and so on. I wish I had. So there's a particular thing about this one. I want to know, what do you think? What happens if now today I have 6 coins, but tomorrow I have 7 coins? Because of course here the result is very simple. I will have one CSV of 6 columns and 1 row. But if tomorrow I decide to buy another coin, like a Bitcoin, for example, then this will produce another row here. But what is your comment about that? Is it going to be a problem? I prefer, so Mark says, I prefer to normalize this list. Can you explain what you mean by normalize? You know, the words normalize and denormalize are these words that have so many meanings. Well, not so many, this one, but they generate quite a lot of confusion. So Mark says 1 column for currency and 1 column for balance. Okay. Yeah, and that's exactly what I would do. Basically, I would not call it normalize, but that's naming, I don't know. I would call it rotate. So the thing is that in Python and R, there's much more portability of rows and columns, because both columns and rows, they must necessarily have a qualifier, which is, in the case of rows, is the index. So it's very easy in Python to rotate a table. And so in this case, okay, when you do the normal action, this becomes 6 columns. But then you rotate it again, and then you make sure that you have just 2 columns. One exactly is carrying the coin name, and the other is carrying the amount, the balance that you have of that coin. So I totally agree, and that's actually what I did. Pivot, yeah, that's pivot is the term. We agree. I'm not able to read all the messages, so wait a minute. Actually, you can, guys, you can also jump in with the microphone. Convert into multiple rows, okay. In BigQuery, it will be 1 column with many rows. Yeah, okay, but the thing is that it is what you make it become, because it's in your hands when you're interpreting a JSON file, unless BigQuery has an automatic interpreter. But there is not a single recipe. You really need to interpret the JSON files case by case, because JSON files are done by other humans, and these other humans may or may not be good at generating these JSON files. So there is not a standard. And I don't believe in a standard interpreter of JSON files. That's why I have decided to move to languages, because case by case, you need to enter into the mind of the person who has created this JSON file, and sometimes argue, like question if it was the right way to do it. Okay.
Those humans really are the worst. You should try to get them out of your pipeline.
Yeah, I totally agree. But if I try to kill them, they are too many. So we need to embrace the challenge. We cannot kill them all. Okay, so I'm opening the third one, which is even more interesting. So if I'm asking you, this is a tricky question, how many, of course, here we have the repetition of 3 dictionaries, but they can be 100. So it would be 3 rows or 100 rows. But how many columns do we have from this JSON? Again, I go to the chat. You want me to show it again? Sorry. So
yeah, show it again. It's a bit complicated.
Class, alt name, decimals, and display decimals. So there are these, and the question is how many columns you expect your CSV file to have. There will be 3 rows in this case, but how many columns? Let's see. And the name of the currency. Exactly, very good. So I would say 5. So I agree with Alex. And Carsten, yeah, he noticed that there are 4 name value pairs, but actually I think the correct way to interpret this file is 5. Yeah, also Carsten agrees. So, and yeah, I had a developer who was helping me to do this, and actually the guy he built a fifth column, just he didn't give it a name. And I said, you need to invent a name for that. So the header of that column must be asset name. And he said, oh, okay, I will give it a name. So he did it well, but yeah, he was not familiar with the fact that a CSV cannot have columns without header. But yeah, so I agree. These for me are 5 columns and 3 rows. So let's go to the next. Get trades history. So this one, okay, all the others files, I was removing this because I'm not interested in this at the moment. But let's see what is happening. Again, we have this result. So this word result basically gets discarded. So we are basically starting our JSON here, more or less. That's what we are doing. So we focus on the content of this value associated with the result. So again, here 2, 4, 6, 8, 10, 12. So again, there are 12 columns, and as we saw earlier, they will turn out to be 13 columns, and we will need to give a name to this one, and we will call it transaction ID, I suppose. And let's arrive to something even more interesting. So in this case, again, we can remove this, not interesting. We disregard this, and then we have the list of open orders. So when I want to buy some coin, I order it, and then when it's available, it generates a transaction. So now the question is, again here, how many columns am I going to have? Well, I'm not bothered to count all these headers, but I make you notice that there is a nested dictionary. This nested dictionary, in my opinion, is not harmful, and it's not even interesting. So if I was the developer that has created this JSON file, I would have not even created a nested dictionary, because it is telling me informations that are unique. It will not happen again that there is the same identical value for order. If I was him, I would have him or her, I would have created just a list of headers like names, like already flattened, because there is this nested structure, but I really don't see the need for that. What is more interesting is this one, traits. This is a nested array. And there is a thing you should know about trading cryptocurrencies. When you make an order, if you don't care about the price, you say, give me at market price, then it will be associated with one transaction. But if you say, I want to buy Bitcoin at 50,000, then they will manage to fulfill your order, not necessarily with one transaction, but typically with more, 2 or 3 or 4 sometimes. So here it will be a list of comma separated transactions. And this is a bit scary, because this is a typical example where what do you do with this column? Are you going to populate it as a column that is comma separated? For sure, a developer who wants to do a quick and dirty job would do that. But we can already begin to think that there is something better. Am I still online?
Yes, you are.
Good. For example, this one, yeah, this is a add order instruction, and I've made an example where instead of one order, there are 3 orders. Okay, so just keep it there. And finally, get open orders. This one, again, we can eliminate this one, which is not interesting. This one, again, is it has a nested dictionary that I really don't need. I don't know why they did it. But basically, we have all these headers as earlier, and we have this nested array, which can have multiple values. So at the end of the day, it's repeating quite a lot. So probably it was an API created by the same developer. And I sort of survived with that. But then I said to myself, wait a minute, what is happening? And Mark was already anticipating my doubt. Okay, this is the minimum JSON, very interesting. What is happening if, this is the example of Wikipedia, fine. What happens if I have this situation. And again, here, guys, prepare. Maybe you can activate your microphone this time because it's going to be more interesting. What is happening when you have a JSON which has a list of name value pairs, and then it has a nested array. You see the square bracket, and then let's think business for a moment. This is a list of orders, like some sales that you do online, and not all orders are shipped all at once. So this order, we were lucky it was done with one shipment, but this order was done with 2 shipments. The question is, and you can imagine the answer, can we flatten also this file? And if not, why cannot we do it? Why is this so different from the others? Because until now, I was okay with nesting, with putting the arrays comma separated, but this time we really cannot do it. What is the risk if we put everything in one denormalized rectangular CSV file? Okay, allora, so I need to check the time, 7:49. So Maxim, hello. So he says, should it be treated as a separate fact table? I don't know what a fact table is because I'm not a fan of Kimball. But if you mean, should it be treated as a separate table? I guess so. But why? The question is, why? What is the problem? So Dan Gallivan says duplicate values. Hello, Dan. Duplicate values in aggregations. Exactly. In aggregations is a very fair point. So let me tell you briefly what is happening. Numbers are not always problematic. We had examples earlier, and there were these numbers. But for example, the number of decimals. These numbers are not additive. They are numbers indeed. You see, they are also in a different color, but they are not additive. You would not do aggregations. So Dan made a very fair point. The problem is when you are aggregating data, because in any case, this you would never do the sum, so you don't care. But when you go to denormalize that structure that I've shown you earlier, it's very likely that I've lost it. Sorry, I have to open it again because I've lost it. It's very likely that you will be interested in this number. And this is okay. The nested one is okay. So this is an order, a line of sales, which is resolved into shipments. So they wanted 200 units, well, actually 2 units for 200 euros. And they were broken into 2 identical shipments of 1 and 1 unit. So these, they don't have a problem. But this number 200 and this number 2, they are additive measures. And in the moment when I go to flatten this JSON into a unique flattened file, then this number 200 and this number 2 will be repeated. And as Dan said correctly, there will be duplicate values in the aggregations. So the grand total at the bottom of the table will be wrong because of the duplicates. Maxim says fact equals with matrix. Yeah, I was a bit teasing. I know what a fact table is, but yeah, in the book that I wrote that you know, Maxim, I basically say people say fact and dimension. I also use these terms, but I don't think that. I think we should stop classifying tables as fact and dimension. In this case, it is 2 nested fact tables. We agree on that. Yeah, but I'm sort of provocative and I say I don't know what is a fact table. But yes, Maxim, you're right. So that would become 2 different fact tables. Totally. So they will become 2 different fact tables. Now, if you look at this CSV that this JSON that I've created, I have added this row, which is basically telling me the ID. You see, for example, let's start from the 1. So it says that this nested shipment refers to this ID, but normally this one does not exist. So a JSON file normally is like this. This is how a JSON file normally is. So because the information is already in the fact that you have nested one row inside S803. So it's already given that information. So the challenge that you have when you go to turn this JSON into not one, but two CSV files is that when you're coding this code that will extract this information about shipments, and it will put them all in a separate CSV file called shipments, you will need to artificially add that column, which in my world and probably your world, the world of relational data, is a foreign key. This is a thing that you need to keep in mind. Nested arrays not only need to go to a separate table, separate CSV file or whatever, but you need to add the information that this row refers to this row of sales. And I'm stressing a lot this comment because in the Kimball theory, basically, there is not the concept of fact tables pointing to other fact tables. Kimball says fact tables are interpreted through dimensions. Nice, but it's a partial vision of the world, because when I'm doing my analysis, and I will show you now my dashboard of Kraken, for example, I need to know when I click on a particular line, I want to know, I click on this sales 02, I want to know what are the two shipment rows that are associated with this sales row. And this in Kimball does not exist. So the is all built around a vision that forgets the connection among fact tables. And the ironic point is that Kimball is even calling them degenerate dimensions. So it's basically like cutting a leg to a person and saying person without leg. No, this person had legs, you just cut these legs. So degenerate dimensions, they don't exist. They are an artifact of Kimball, who kills the relationship that exists in the original data among fact tables. And although that is a very precious information, and beyond that, Kimball says, okay, and then we create the key artificially by merging all the foreign keys. Well, that's also bad for two reasons. First of all, because not always the combination of the foreign keys becomes a unique primary key. Not always. And the second is that you had a key, you threw it away, and then you're using a combination of foreign keys to make again that table unique. I'm talking, of course, in this case about sales. So you have a key, which is the sale ID. If you throw this away and you make a combination of these, it's even if it's unique, you have killed the relationship between these two tables that, as Maxime says, are actually fact tables, and I agree with him. So this is bringing me a bit towards the end of the presentation with one conclusion. As you saw here, we had nested dictionaries and nested arrays, like this is an array, this one. So we have discussed, and we all agree that flattening the JSON is definitely no. And I wanted to make a conclusion. There's actually a naming convention that I never remember, parent and child. I never use this. I like to speak about foreign key and primary key. But okay, when it comes to sales and shipments, the table with the primary key is called the parent, and the table with the foreign key is called the child. I had to search it before the speech, because I never remember that, because I find it a bit illogical, because actually typically the table that has foreign key is bigger, so whatever. But what matters is if we call this the parent and this the child, then the conclusion is that nested dictionaries, if we really want to make them as separate tables, they have to become a parent table. So basically, if I remove a nested dictionary from here, I say, okay, you know what, instead of keeping them all aligned in one table, I'm happy to keep this file as a separate file, and I will call it address details or address or whatever. This will become a self-standing table, but it's a nested dictionary, okay? So it's easy. This table will become a parent table. So basically, it will become a table that my original JSON points to, while instead nested arrays become a child table. You remember we had sales and shipments, so we have nested shipments. So again, in this case, I can go here. Shipment is nested. I decided to make it a separate table. Okay, fine. I will call that table shipment. Okay. I need to be sure that I restore that foreign key information that I made it explicit initially, but very often it is not. And that is a foreign key because we will need that foreign key because the nested array will become a child table. So it will become a table that has a foreign key that points to the table that is the main JSON file that we have broken into pieces. This concludes my thought that I had with you, and now I would really love to have a question and answer